Hello everyone. This video is on the Knewton Alta assignment section 3.2 part 2 called Evaluate Piecewise Functions. So in this video I'm going to be going over a preview version of this assignment. So please understand that the questions I see here may or may not be the same questions that you see when you work on the assignment yourself. But the objectives are the same, so the questions should be similar enough to where, so that watching me go over a few of them here will hopefully help you when you work on the assignment on your own. Alright, so here's the assignment page. You'll have the title, mastery bar, your objectives. It looks like there's only the one objective here, so this should be hopefully quick. And then a question related to that objective, and at the bottom of every question you should see a feedback button, which allows you to send feedback to Knewton if you wish. The instructor cheat button you will not have. Right, that's for instructors only. But you will have the more instruction button. Right now you can click on this if you're ever struggling with a topic. It'll take you to some reading, some videos, more instruction. And then you'll have questions related to that instruction, and going through those questions is going to take you through the assignment just as much as these original questions will. So there's nothing wrong with that. Alright, so the objective is evaluate piecewise-defined functions. Alright, so a piecewise-defined function, it's still a function. Right, so every input should give me exactly one output. But it's a function where the way you calculate the output changes depending on where the input comes from. Right, so I'll write this piecewise defined function out here and explain what I mean by that. Right, so here's the function we're given, and again this is called piecewise. Right, there are 3 rows, 3 pieces here. Now usually I see the words if in between these. I'm going to put them, alright, the word if. Because again, the way you calculate the output, the input is x, right? That's not changing. The function notation still tells you what the input is. And then the output is f of x, but how you calculate the output, right? How you calculate the output, which rule do you use? How you calculate output depends on where the input comes from. It depends on the value of the input. So over here we have the conditions that need to be met in order to use that particular piece, that particular rule. So for instance, if you plug in a value of x that's less than 1, then this rule is the one you're using to calculate the output. You take the input and then subtract 3. But if that's not true, if the input is greater than or equal to 1 and at the same time less than 3, then this is how I calculate the output. You square the input and then add 1. But if neither of these are true and the input is greater than or equal to 3, then this is how I calculate the output. I double the input. All right. Don't use all the pieces. Don't use all the pieces. That is a common mistake I see happen way too often, where people just take whatever the input is and plug it into all the rules and give me 5 different outputs, 3 different outputs, 2 different outputs. This is still a function. Right? These are still functions, meaning every input should give me 1 and only 1 output. Right? So they're asking us to find the value f of 1. Right? So the input is 1. Alright, the input is x equals 1. Now we have to look at the conditions to see how to calculate the output. Is 1 less than 1? Is 1 less than 1? No. 1 is not less than 1. So, I don't use this rule. The x minus 3, I'm not using that one. Is 1 less than or equal to 1 and 1 less than 3? And again, just replacing x with 1 in this condition. Is this true? Yes. Right? 1 is less than or equal to 1 because of the equal part, and at the same time 1 is less than 3. So that means we use the second rule, x squared plus 1, to calculate the output. All right, and that's it. You stop. Don't go into the third rule, don't go back to the first rule. You only are going to be plugging your input into one of these things. One rule. Every input gives you one output. So, f of 1 will be 1 squared plus 1. Replacing x with 1, and that's 2. Right. And that's all they want. That is all they want. Very, very simple. You just have to pay a close attention to which rule you're going to use by saying, hey, what's my input? Which condition does it meet? And then that'll tell you how to calculate the output. So f of 1 is 2 here. All right, and then after you submit an answer, it'll tell you if you're right or wrong, and then give you some sort of answer explanation. Please read through these. Figure out why you were right. Definitely figure out why you were wrong if you got it wrong, and try to learn from your mistakes for the future. Okay, so next question. So same function. All right, this is the same exact. Again, these are called piecewise-defined functions here. Where they're breaking up into three pieces. The way you calculate the output changes depending on the input. But now they're asking us to find f of 3. Right, so once again, I'll go back to my paper. The same function is written. Okay, but now we're asked to find what is f of 3. Okay, so now the input is x equals 3. Right? That's the input. And then again, I'll go down my conditions. Now you can obviously do this mentally. You don't have to write this out, but let's look at the top condition. Replace x with 3. Is 3 less than 1? No. 3 is not less than 1. So again, I'm not using this first way to calculate the output. I'm not using x minus 3. Replace x with 3 in the second condition. Is 1 less than or equal to 3 and 3 is less than 3 at the same time? Well, 1 is less than or equal to 3 is true, but 3 is less than 3 is not true. So this is false as well. No. So I don't use x squared plus 1 as the way to calculate the output. And finally, the last piece, replace x with 3. Is 3 less than or equal to 3? Yeah, the equal part is satisfied. Yes. So that tells me I'm going to use that rule. I'm going to use 2 times x to calculate the output. And I apologize if you hear a dog in the barking in the background. Okay, so f of 3 is going into 2 times x. Replace x with 3. 2 times 3, which is 6. And that's it. That's it. Right? Every input should give me one output. It is a function. Don't plug it into x squared plus 1. Don't plug it into x minus 3. Only the 2 times x, right? Because that's the only condition that is met. And that's all they want, right? F of 3 is 6. Great. And again, please read through your answer explanations. And probably just got one more of these where we're going to evaluate a couple things. So I'll write this out. And they want us to find f of 0. You know what? I don't even need to write it. I'm not going to write this one. Should be easy. I feel these are easy. I hope you do too. They want f of 0. Right? The input is 0. Look at the conditions on the right here. Is 0 less than 0? No. Is 0 less than or equal to 0? Yes. And is 0 less than 3? Yes. So this second condition is the one that's satisfied. So the way I calculate the output is this rule here. Well, f of x equals x. So f of 0 would be 0. So the output is 0 when the input is 0 for this function. Okay, and then one more. Just going to scroll down here. Right? Same function, but what's f of 3? So again, look at the conditions. Is 3 less than 0? No. Is 0 less than or equal to 3? Yeah, but is 3 less than 3? No. Is 3 less than or equal to 3? Yes. So the third rule is the one I'm using to calculate the output. So f of x equals x squared minus 1. And then f of 3 would be, 3 squared minus 1. 9 minus 1, or 8. That's all they want. 8. Type the output. Wonderful. And that's it. All right, I feel these piecewise defined functions are easy to evaluate. But just remember that they are functions. Every input should give you one output. Don't plug the value into every single rule you're given. Figure out which condition is met first, and then plug into that rule. All right? And that should be it for this preview version of this assignment. As I said at the top of the video, please understand that the questions I saw here may not be the same questions that you see, but the objective is the same. So the questions should be similar. The way you do them should be similar. So I'm hoping that watching me go over these few examples here help you out when you're working on the assignment yourself. And thank you very much for watching.